A short lesson on algebra patterns, finding the missing numbers. There'll be a couple of types we're looking at. The first and maybe easiest one is the common difference. That's when the same number is added or subtracted each time. Here's an example. Find the next three numbers. Well, if you look, you'll see that each time 4 has been added. But why is it called the common difference? Well, if we take the two numbers, and we always take the second number minus the first, we'll get 7 subtract 3 is 4. And if we look at the next one, 11 subtract 7 is 4. So there's your common difference, the difference between the next term and the previous term. So let's add 4 to each of them. 11 plus 4 is 15, plus 4 is 19, plus 4 is 23. So the next three numbers are in green there, 15, 19, and 23. Here's another example of common difference, but this time the numbers are before the numbers given. So find the first three numbers. Again, let's have a look at the difference. This time it's minus 3, because if I work it out, I'm going to say 44 take away 47, because I'm going that way from right to left. I'm going to get negative 3, so I have to take 3 away each time. Well, what's 41 take away 3? It's 38. Take away 3, 35. Take away 3, 32. So my answer will be 32, 35, and 38. Squares is another thing you should look at. The perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, etc. So try and remember those numbers, 1, 4, 9, 16. That's 1 times 1, 2 times 2, 3 times 3, 4 times 4, and you just carry on. So 5 times 5, 6 times 6, etc. The easiest example, I guess, would be this, 149. Well, the first thing we would normally do is check, is there a common difference? No, because the one went up by 3 and the next by 5. So it's not a common difference. Then what we must do is check, is it one of the perfect squares? Well, obviously in this case it is. So it's 1 squared, 2 squared, 3 squared. We know the next one will be 4 squared, then 5 squared, and 6 squared. So the next three numbers would be 4 times 4, 5 times 5, and 6 times 6. In other words, 16, 25, and 36. Sometimes it's a little trickier, like this one here. Well, let's check for common difference first. That goes up by 5 and then 10, so it's not a common difference, so we're not going to use that one. Let's check the squares. Well, the squares we know are 1, 4, 9. Now that's not 1, 4, 9, but can you see that there's a relationship between the 1, 4, 9 and the 2, 8, 18? Each of them are multiplied by 2. 2 times 1, 2 times 4, 2 times 9. So in other words, it's your squares, but multiplied by 2. So the next would be 2 times 4 squared, 2 times 5 squared, and 2 times 6 squared. So 2 times 16, 2 times 25, and 2 times 36. And you get your answer as 32, 50, and 72. Type 3 are the cubes. So the cube of 1, of 2, of 3, of 4, etc. So 1 times 1 times 1, which is 1, 2 times 2 times 2, which is 8, etc. So the obvious and easiest one would be this. Check to see whether there's a common difference. No, because you add 7 and then you add 19. Check to see whether it's the squareds. No, and there's no relationship between the two. You can't double each of them or triple each of them or whatever. So it's not those. Then check your cubes. Is it 1 cubed, 2 cubed, 3 cubed? And yes, it is. So the rest would be 4, 5, and 6 cubed. And do that on your calculator. 4 cubed gives you 64, 5 cubed gives you 125, and 6 cubed gives you 216. So your answer is 64, 125, and 216. And then the last type would be just patterns, things that you can see. So when you find that type 1 to 3 won't work, go for patterns. And usually in patterns you're given more numbers, so it's usually a giveaway. So let's just check the difference between each of them. Well, the first one you add 1, the next one you add 2, then 3, then 4. So straight away you can see there's a pattern. The next one would be 5 and then 6. So 13 plus 5 is 18, and if you add 6 you get 24. So it's time to see whether you can apply that. Go to the online course and do missing terms checkpoint and see if you can do it until you get 100%.